Hello there, this is Surya Teja. My project is about the voice control home automation. Today we will discuss about what is voice control home automation, for whom it will be useful, what are the benefits, and what are the electrical devices can be controlled by using this voice control home automation. Let's begin our seminar. Problem statement of our project is, in the present day, home robotization is getting the chance to be particularly essential with the true objective of advancing our life condition. It means if we compare our lives with American, Chinese, and Japanese, they are using advanced technologies than us. For every simple task, they are using home automations and advanced technologies. But we are still using old principles and old technologies only. In such a way, we should also implement these type of home automations and advanced technologies in our day-to-day life also. With this, we can perform the task very quickly and we can also save the time. By implementing this voice control home automation, an individual get control over all electrical devices present at home by sitting at one place by using the voice command. Wow, I really like this idea. Operating the all electrical devices by using voice command is amazing idea. See, this voice control home automation will helpful for physically handicapped people and old age people because they will find it difficult to walk and switch on the switches for operating these electrical devices. If we implement this voice control home automation, they can quickly control these all electrical devices by using their voice commands only. This is our problem statement. Objectives of project. Gadget controlling by switch or remote is old idea now. We can control any home apparatus by utilizing our voice. See, up to 2007 we are using the keypad mobiles. Now we are using the smartphones. There are much difference between these keypad mobiles and the smartphones. We can access any information in the world by using these smartphones, but we can't access such type of information by using these keypad mobiles. Means we are upgraded from the keypad mobiles to the smartphones. In such a way, we should also upgrade our home by using this voice control home automation. Working physically to control these electrical devices is old principle. We can control all the electrical devices by using our voice command only. This is the main objective of our project. And the scope. Scope is we can perform so many various applications by using this voice control home automation. For the project purpose, we are using just a light and fan as a demo. This is problem description. For the project purpose, I took 4 control devices with 8 different types of voice commands. These are the voice commands. For every command, a task will be performed. For example, I'm giving a command called turn on light, the lights will be turned on. If we give the command called turn off light, oh, the lights are turned off. It's really amazing. Now I'm giving again the command called turn on lights. Yes, lights are turned on. In this way, we can control all the electrical devices by using the voice command. Whenever we give these commands, Arduino checks whether these commands are correct or not. If it is correct, the task will be performed. If not, the task will not be performed. Because we already include these commands in Arduino code, so the Arduino checks every time whenever we give this voice command. When we send the voice command through the app, then the Bluetooth module receives this voice and passes to the Arduino. Now Arduino checks whether these commands are correct or not. If the commands are correct, then it sends a low input to this relay module. Then this relay module operates all electrical devices. If you want to switch, if you give the command called switch on, turn on the light, then this relay module turns on the light. If you give the turn off the light, then this relay module turns off the light. In such a way, this voice control home automation works. See, for example, when we send the command called turn on light through the app, then it passes to the Bluetooth. Now Bluetooth sends this command to the Arduino. Arduino checks whether this command is correct or not. Turn on light is a correct command, so Arduino sends a low input voltage to this relay module. Now the relay is on mode, and then the devices will be turned on. Now we given the command called turn on light, so the lights will be turned on. If you send the command called turn off light through the app, and it passes to the Bluetooth. Now Bluetooth again sends this voice commands to this Arduino. Arduino checks whether this command is correct or not. Turn off light is the correct command. So this Arduino again sends an input voltage to this relay module. Now the relay module is in off mode, so the device will be turned off. Means we are giving the command called turn off light, so the light will be turned off. This is a brief problem description. Block diagram. A person is sending the voice commands through mobile application to Bluetooth module. Now the Bluetooth module sends these voice commands to Arduino. Arduino checks whether these commands are correct or not and displays a status on LCD display. And if the voice command is correct, then it sends a low input voltage to the relay module, and the relay module control all the devices according to the given command. This is a block diagram of our project. Requirement specification. For every project there will be a requirement specification. For our project we should have at least 256 MB of RAM and hard disk space over 200 MB, better design, mobile, Android application, users, Arduino Mega, interfacing relays with AC and DC power sources, Arduino IDE, breadboard, wide, embedded programming, and HTML and CSS. Functional requirements. Different types of project have their types of specific functional requirements. In case of our project, we are using the voice recognition performed via Bluetooth medium. So we need an Android application in between this smartphone and this Bluetooth. The Android application takes the input from the user and sends it to the Bluetooth. To accomplish this criteria, having the application that could be supported on the Android phone, we are using this Android application. Another functional requirement is the Android operating system must be the minimum version of Lollipop. So any version of the phone below this will not be supported, because the versions below this will not have many features, may not connect to this Bluetooth. So that's why the mobile should have minimum version of Lollipop. And then we need to open this Android application, and for the first step the user must press the connect button to start the connection. So this will cause the connection between the mobile and the Arduino device. In our Android application, the user have to press this button called connect. Whenever the user presses the button to connect, a connection would take place between this Android device and Arduino. And then this user have to press the button called start. This button will initiate the process of taking the voice as input from the user and send it to the Bluetooth after converting into the text format. Now, the processed input will be referred to this Arduino device via Bluetooth, and the Arduino device checks whether these commands are correct or not, as the Arduino board is interconnected with the other utilities. So once the execution will takes place, it will react towards the connected utilities to perform the actions accordingly. Thus, the initial input from the user will get the output as the stages produces. Non-functional requirements. There are many non-functional requirements. We will see one by one. As the operation of product based on Bluetooth, so it's important the application containing mobile must have Bluetooth function, as if the mobile does not have Bluetooth function, we can't give voice commands to this Arduino device. So the mobile machine should have the Bluetooth function. And another non-functional requirement is the system can only work once at a time, means the input is given by the user, it will be perform an action in the form of controlling home utilities, and no second input will be identified unless the first given input is concluded. It means I have given the command called turn on light. Now it is in processing state. I should not want to give another command called turn off light while it's processing. The first command should be concluded, then after we should give it the second command. This is a non-functional requirement. Another non-functional requirement is input validation is important. So if the user goes with such an input which is not identifiable, it will not be processed. So it's important to give an input which is clear, logical, and smooth without description. It means, see, I have turn on light is a command. Now I am giving the command called lights please turn on. Is the command is correct? No. If you use such type of commands to Arduino device, the task will not be performed. The commands which are given in the Arduino code should be given by the user. This is also a non-functional requirement. Receiving the data from the mobile will cause the execution of program at Arduino device. So If data is not received by the device, it will not respond for anything until some connection is established and data is sent through Bluetooth module. If a task will be performed according to the given data. If the data is not given, the task will not be performed. So we need to have a connection between this Bluetooth device and Arduino, and the data is also sufficient. If the data is not given properly, the task will be not performed. So it is also a non-functional requirement. Performance requirement. Performance requirements. Performance requirement states how the thing should perform and the standards that they must achieve in a specific set of circumstances. First one is flexibility. A home automation system needs to adapt to different users and their requirements. Means different types of users have different types of requirements. The home automation system needs to adapt all the requirements given by all users. It needs to be able to recognize the voice commands irrespective of their age, gender, accent, and pitch. It must also work with appliances the user already owns so that he doesn't have to purchase additional appliances. The system must have multiple interfaces so that the user can choose whichever is the most convenient to him. Interfaces can include a simple voice command interface, a mobile application to control devices. And the second one is security. Modern home automation are also used to lock and unlock the doors in a house so that we can have a secured home than we compare to normal homes. Uh, Another person other than you can't access your home if you implement this voice control home automation. It is obvious that if the system isn't designed with a focus on security, this could be a major threat to its owners. Also, if the system works on a wireless network, it is imperative to ensure that the channel is secure. Before any transmission is sent, a system that is built from the ground up with emphasis on safety. So if we implement this voice control home automation, our home will be secured and these doors will be locked and unlocked by through your voice only. So it must be the best feature in this voice control home automation. Cost. A major factor that decides how successful a home automation system is the cost and the user has to incur. A system may have all the latest bells and whistles, but the user cannot afford if he simply will not buy it. Cost includes both the initial cost of the product as well as the cost of installation and long-term maintenance. An automation hub may appear to be cheap, but when you consider the cost of additional appliances you need to buy along with the hub, the cost adds up. Also, if the system is wired, the cost of labor that is needed for installation needs to be kept in mind. And the fourth one is response time. Everyone today is used to instantaneous relates. Therefore, in order for a home automation system to be truly useful, it must respond to inputs in the short time possible. So, algorithms give superior results for command recognition, but the time take for computation is not ideal. An ideal algorithm would be the one which strikes a perfect balance between the computational power and the response time, so that whenever we use a voice command, we have a quick response with this home automation system. It means if I give a command called turn on light, we have quick response and the lights will be turned on within a seconds. So the response of the time is very good when we compare with normal home automation. Voice control home automation should have these type of performance requirements. Design constraints. The following diagram shows the design constraints of our project. This is a Bluetooth module, sends the voice command to the Arduino board. Then Arduino board sends a low input voltage to the relay board. Now the relay board performs the actions like on and off to the electrical devices. Limitations. Other requirements are considered as limitations, which are the vital performing this all process effectively and in a smooth manner. So system can be used as many as appliances needed until and unless it doesn't break the rules of restriction requirements. If it breaks the restriction requirements, it can't perform the tasks. As this project is based on Bluetooth, so for performing the task, so it's compulsory requirement that the facilities are openly available to be used. Range. The major point is the what to consider its limitation of range. As we are relying on these services through the Bluetooth module, we need to be careful about the range of these facilities. See, the Bluetooth range is very short when we compare to the internet or any other. So it will work at a certain range only. It can't exceed from that. So we should keep in mind the range should be very less. We should not go beyond to it. So it is important while performing the task, keep the distance in mind, because if you are using the Bluetooth, then the Bluetooth range is only 10 meters. Above it can't works. It can't takes this voice commands to this. So we need to be within a radius of 10 meters only. But we can overcome this difficulty by using internet. If we use internet in case of Bluetooth, we can access from all over the home. But in our project we are using Bluetooth modules, so the range is 10 meters only. Power supply. There are also some limitations on the power supply. The system will require 24/7 power supply, because these all electrical devices work only by using electrical power. So to turn on or turn off these electrical devices, we must need electrical power 24/7. And then voice will be one of the major problems for the users, because this voice is made different from one user to another user, and the pitch accent will be also different from one user to another user. So in this project we are using this Bluetooth voice recognition, so it requires a good accent voice. If the people does not have any good accent voice, they feel some problems. So this Bluetooth voice recognition may not recognize their voice. Data flow diagram. Data flow diagram states how the data transfers from one phase to another phase. We have three levels of data flow diagrams. The first one is the level 0. Now the voice command is sent to the Android application. Then it sends to the Arduino. Arduino sends a low input to this application, controls the devices. If you go the much deeper, we have level 1 diagram. This is the level 1 diagram. Now the user giving this voice command to the Android app. Android app gives this text command to the Bluetooth. Now the Bluetooth sends this text command to the Arduino. Arduino sends a signal to the appliances. If you see the level 2 diagram, now the user is giving the voice command to the Android. Android sends the voice command to the Bluetooth. Now Bluetooth converts them into the text command and sends to the Arduino. Arduino now sends to Arduino. Arduino performs the tasks like on and off and stores the data. Structure chart. Structure chart represents the hierarchical structure of all modules. See, this is a hierarchical structure and these all are the modules. It breaks down the entire system into lowest functional submodules and functional modules. These are the functional modules and here are the sub-functional modules. Now the start and the initialize the Bluetooth modem and realize the data transfers to this modem, and then it goes to the Arduino and checks the data whether it is correct or not, and this goes into one of this manual and perform the task like on and off. The next one is use case diagram. Use case diagrams are considered for high level requirement analysis of a system. When the requirements of a system are analyzed, the functionals are captured in the use cases. See, here the user giving this voice commands and then converted into the text and sends to the Bluetooth. Now the Arduino receives this command and executes them, then sends to the relay, and the utilities or performs the task like on and off. Class diagram. Class diagram is a static diagram. It represents the static view of an application. Class diagram is not only used for the visualizing, describing and documenting, but also we can use for different aspects of a system, for the constructing executable code in a software application. Now the users are giving login ID, access object and receive message and logout. Then we have an application have automation and security. It means the automation we have the electrical devices. In security we also have some security features. Then in this automation, based on the command, the action will be performed. Object diagram. Object diagram represents a specific instance of a class diagram at a certain moment in time. When represented in visually, you will see many similarities to the class diagram. An object diagram focuses on the attributes of the set of the objects and how those objects relate to each other. So this is a transfer and this is a controller, and this controls all electrical devices by using your commands. The next one is state chart diagram. The state chart diagram describes the flow control of data from one state to another state. It defines the condition in which an object exists, and it changes when some event is triggered. The most important purpose of state chart diagram is model lifetime of an object from creation to termination. Now, this mobile, the commands goes to the Bluetooth, then to the Arduino, and Arduino to the relay, and relay to the electrical devices. In which here the commands are took successfully. If it not, the commands are not revealed, it exists or it's terminated from this. Next one is activity diagram. Activity diagram is basically a flow chart to represent the flow from one activity to another activity. The activity can be described as an operation of a system. The control flow is drawn from one operation to the another. The flow can be sequenced, branched, or concurrent. These activity diagrams deal with all type of flow control by using different elements such as fork, join, etc. So this is activity diagram. Now the user gives the voice commands, then it recognizes the voice and converts them into the text and sends to the Arduino. Now Arduino, if the code is matched, then sends to the relay mode and executes the operations such as on and off. Sequence diagram. A sequence diagram is a type of interaction diagram because it describes how and in what order a group of objects works together. These diagrams are used by the software developers and business professionals to understand the requirements of a new system. Sequence diagrams are sometimes known as the event diagrams and event scenarios. Now the user giving the voice commands to the mobile application and sends to the Arduino Uno. Now Arduino Uno checks whether these commands are correct or not. If it's correct, it's sent to the relay board and executes these operations called on and off and ends the process and come out from these operations. Collaboration diagram. A collaboration diagram is a type of visual presentation that shows how various software objects interact with each other with an overall architecture and how users can benefit from this collaboration. A collaboration diagram often comes in the form of visual chart that resembles a flowchart. It can show at a glance how a single piece of software complements other parts of the greater system. See, in this, there is the owner has the login form. Whenever he log in, we have the access to the system. And this is a collaboration diagram of voice control home automation. Component diagram. Component diagrams are different in terms of nature and behavior. Component diagrams are used in the model the physical aspects of a system. Wait, what is the physical aspect? Physical aspects are the elements such as executables, libraries, files, documents, etc., which reside in a node. The component diagrams are used to visualize the organization and relationship among components in a system. These diagrams are used to make executable systems. See, this is the mobile and the commands is given to this Bluetooth. Now Bluetooth sends the commands for the Arduino and Arduino sends the commands to the relay and relay operates the electrical devices. Deployment diagram. The deployment diagram visualizes the physical hardware on which the software will be deployed. It portrays the static deployment view of a system. It involves the nodes and their relationships. It ascertains how software is developed on the hardware. It maps to the software architecture and create in design in the physical system architecture, where the software will be executed as a node. Since it involves many nodes, the relationship is shown by utilizing the communication part. This is the deployment diagram of voice control home automation, where the user gives the voice commands to the mobile and sends to the Bluetooth and goes to this Arduino and goes to this relay and external devices. Then the operation will be performed on electrical devices. After the completion of UML diagrams, it's time to test this voice control home automation. This type of test is targeted to the voice app developers. They need to do unit testing to ensure the code is working correctly in isolation. As you perform unit testing while coding, you need it to be fast and it doesn't interrupt your coding pace. Unit testing is a software testing technique by means of which individual units of software of the group of computer program of models Usage procedures and operating procedures are tested to determine whether they are suitable for use or not. Unit testing of software product is carried out during the development of an application, and individual component may be either an individual function or procedure. Unit testing is typically performed by a developer. Integration testing. Integration testing is the process of testing interface between the two software units or modules. It focuses on determining the correctness of the interface. We have four types of integration testing. The first one is the Big Bang integration testing. It is the simplest integration testing approach where all modules are combining and verifying functionality after the completion of individual module testing. In simple words, all modules of the system are simply put together and tested. If any small error is occurred, the modules are reported to Big Bang integration testing, very expensive to fix. Bottom-up integration. In bottom-up integration, each module at lower levels is tested with higher modules until all modules are tested. The primary purpose of this integration testing is each subsystem to be test interfaces among the various modules making up the system. This integration testing uses the test drivers to drive parse and appropriate data to the lower level modules. The third one is top-down integration. Top-down integration testing is used in order to simulate the behavior of the lower modules that not integrated. In this integration testing takes place from the top to bottom. First, high-level modules are tested and the lower-level modules are finally integrated to the lower-level modules to have high-level modules to ensure the system is working as intended. The fourth one is mixed integration testing. A mixed integration testing is also known as sandwich integration testing. A mixed integration testing follows a combination of top-down and bottom-up testing approaches. In top-down, testing can start only from top-level module to have been coded and unit tested. In bottom-up approach, testing can be started only after the bottom-level modules are ready. A mixed integration testing is also called as sandwich integration testing. The last one is Gantt chart. Definition of problem and outline the problem may take 3 days. Preliminary requirement analysis may take 7 days. Literature review may take 14 days. Feasibility study may take 3 days. Analysis, requirements, and specifications may take 7 days. Hardware assembling and disassembling may take 21 days. Technological specification may take 3 days. Software design and development may take 21 days. Design and code the program may take 14 days. Evaluation may take 10 days. Testing may take 11 days. Implementation may take 7 days, and finalizing may take 7 days. So approximately we may take 5 months to complete this voice control home automation. Conclusion. In this project, we have successfully implemented voice control home automation system controlling relays using Arduino with Bluetooth model. This project can be used for controlling n number of input control by extending the number of relays. For the project purpose, we just used 4 electrical devices. But in real time, we can use n number of electrical devices by using this voice control home automation. Our implemented module is more reliable and flexible in order to control any electrical device. The coverage area for wireless control is 10 meters. By above this 10 meters, this function may not work. So the user must be within this radius of 10 meters only. Hence, this project can be useful for real-time voice control home automation. Thus, Arduino-based voice control home appliances proves to be better remote control operation on home appliances using Bluetooth module. This project can extend for many automation applications such as industrial automation, automotive, military, healthcare, transportation, and so on. Further, the coverage area needs increased by using some GSM modules. Appendices. We may gather the component for the project from different sources like Arduino Uno, breadboard, and other some stuff from online. On references, I took the information from these websites. And thanks for giving this opportunity. Don't have a good day. Have a great day.